Now, sometimes you're going to have a relationship that contains both a direct and an inverse variation. So, if a variable varies directly, it will be in the numerator. In other words, it's representing multiplication. And if it varies inversely, it's going to be in the denominator, which represents division. So if you have something that looks like y equals k times x over z, it would vary. We would say y varies directly as x and inversely as z. So let's see if we can take this and put it into context. So the change in temperature of an aluminum wire varies inversely with its mass m and directly as is the amount of heat energy E transferred. Let's just stop there. Let's take what we know, apply some variables. We already given two variables, m and E. What we don't have is this thing, the change in temperature. Now, thinking to what you've done in science classes, especially like physics and chemistry, change is represented by a triangle. We call that a delta. T, we're going to give it a capital, or temperature, we're going to give it a capital T. So we're going to say the change in temperature, delta T, varies directly as inversely as mass m. So that's the m is going to be in our denominator, and mass m, and directly as the amount of heat energy E. So we're going to say it's going to be K times E over m. The rest of it, we're going to look at this and we're going to say the temperature of aluminum wire with a mass of 0.1 kilograms rises 5 degrees Celsius when 450 joules, capital J, of heat energy is transferred to it. Well, let's start plugging that in. So, temperature rises 5 degrees, not 50, sorry, 5 degrees Celsius equals K. We still don't know what K is. Our energy that we're using is 450 joules. So we got K times 450 over our mass of 0.1 kilograms. Now, what we're going to need to do to figure out the rest of this, it says how much heat energy must be transferred to an aluminum wire with a mass of 0.2 kilograms to raise its temperature by 20 degrees Celsius. We got to figure out what K is. So in order to figure out what K is, I'm going to take both sides of this equation here, and we're going to multiply it by 0.1 just to cancel those out. So we're also going to multiply this one by 0.1. So we have 0.5 equals K times 450 joules. Now, if it helps you, I'm going to put 0.5 as 1/2 equals K times 450. Now, to solve for K, we're going to divide both sides by 450. The right side's pretty easy to figure out. We get K there. And then 450, 1/2 divided by 450 is also 1/2 times 1 over 450. So it's the super nice convenient fraction of 1 over 900. It's a really small number, but we're going to make it work. So that means if we're using this in a general equation, we got delta T equals 1 over 900 times our heat energy divided by our mass. So the last thing, again, going back to the final question, is how much heat energy is transferred to an aluminum wire with a mass of 0.2 kilograms. So that's going to be our M. And then our temperature is 20 degrees Celsius. So we got 1 over 900 times the E that we don't know over 0.2. I'm going to start by multiplying both sides by 0.2. Oh, that looks like a 6, sorry. 0.2 on both sides. 0.2 is 1/5, so that's actually 4 equals 1 over 900 times E. And to solve for E, we're going to multiply both sides by 900 to cancel out that 1 over 900. So we end up with 3,600 equals E. Now, applying that to a unit, that's 3,600 joules Or if you want to get fancy, that's 3.6 kilojoules. So it would take 3,600 joules or 3.6 kilojoules to raise that temperature.